Let's now take more examples in order to illustrate this concept of aromaticity. Let's take cyclopropene, and let's see if we can apply the aromaticity rules. Now, cyclopropene is cyclic. It is cyclic, of course. Yes, that is fine. So that's one requirement fulfilled. Cyclic. Is it flat? It can be flat. It can be planar. The more important question is it conjugated? Well, if you look at the structure of cyclopropene, you would find, of course, there is a double bond here. So this carbon is sp2 hybridized. This carbon is sp2 hybridized, whereas that one is sp3. Now, if the hybridization is sp3, then all orbitals have been used in hybridization or were mixed 1s with 3 p orbitals. So in other words, there is no p orbital on that carbon. And this is very, very important. So there is no p orbital on that carbon. And of course, an absence of a p orbital is enough for conjugation to be lost. If there is no p orbital, that carbon cannot form a pi bond, in other words, with a nearby carbon. So therefore, cyclopropene is not conjugated. That's because there is an sp3 hybridized carbon on it. There is no p orbital, and therefore it's not conjugated. And of course, that's enough for cyclopropene not to be aromatic. So therefore, cyclopropene is anti-aromatic. So this is an example or another example of an anti-aromatic compound. Let's then take another one, cyclopentadiene. So something like that. This is cyclopentadiene. If you check cyclopentadiene, I'm sure you would find out, you could tell very quickly that cyclopentadiene is anti-aromatic. That's because this carbon is sp3 hybridized, which is enough actually for this compound to be not aromatic or anti-aromatic. So this carbon is sp3 hybridized. In other words, there is no p orbital, and that's very, very important as we now understand. Of course, other carbon atoms are sp2 hybridized as usual. That's because there is a double bond or a pi bond between each of them and a nearby carbon. Of course, cyclopentadiene is cyclic. It is not conjugated, therefore. That's because of the absence of a p orbital. And of course, if it's not conjugated, therefore it is anti-aromatic. So this is an example of an anti-aromatic compound. And again, the idea of these two examples is the absence of a p orbital. If a cycle or a compound which is cyclic does not have a p orbital, then conjugation is lost. This is more or better illustrated actually by cyclopentadiene. There is conjugation here, but conjugation is lost by this carbon because there is no p orbital. So therefore, the molecule is not conjugated, and if it's not conjugated, therefore, it is not aromatic.